Direct and inverse proportions. Section 1. We know that multiplying or dividing the first term and second term of a ratio makes literally no effect whatsoever on the ratio. And if you were to consider the first term to be y and second term to be x in the Cartesian coordinates, then we can see that it actually traces a straight line, or we can say it behaves like a linear function. Linear functions are the functions represented by y equal kx, one value mapping to other value through a constant. And basically all this talk is to lead you to a concept called direct proportions. Now we will see what it is. Consider one value of x mapping to a value in y, and if x increases or decreases, then y should also increase or decrease with the same ratio. And let's name it r1 by r2, which is also equal to y1 by y2 and x1 by x2 under this newly introduced notion. So that's direct proportions, and now let's see the inverse proportions. Just like in the direct proportions, this thing has its own rule, and it is y equals k by x. And in here, if x increases, y decreases, and if x decreases, y increases, again with an equal ratio. And let's use the same notation r1 by r2, which is in here is equal to y1 by y2 and x2 by x1. And let's see all of this with a short example. Suppose the value of x is 2 and y is also 2, and consider that they are in direct proportions. So if x doubles, y should also double, with r1 by r2 equating to half. And if we consider them to be in inverse proportions, then upon x doubling, y should reduce by half, with r1 by r2 equating to 2. The thing to take away from all of this is when it's direct proportions, y1 by y2 equals x1 by x2, and when it's in inverse proportions, y1 by y2 equals x2 by x1. Now let's move to section 2, problem 1. If 15 men working 9 hours a day can reap a field in 16 days, in how many days will 18 men reap the field working 8 hours a day? Let's see how these things are related to each other, whether they are in direct proportions or in inverse proportions. So as the men increase, the days that they have to work for decrease because they can finish the work in less time, making them to be in inverse proportions. And if they work for less hours per day, it's going to take more days, making this also to be in inverse proportions. Now here we are going to take days to be y's and men multiplied with hours per day to be x. And to put it simply, the reason why we multiply them together is because they are dependent on each other. So now we know how they are related, and we can use the appropriate ratio principle to get to our answer. Problem 2. A contract is to be completed in 46 days, and 117 men were set to work 8 hours a day. After 33 days, 4 by 7th of the work is completed. How many additional men may be employed so that the work may be completed in time? Each man now working 9 hours a day. Step 1. Laying out the picture. So here we go. Less work, less men. Direct proportion. Less days, more men. Inverse proportion. More days per hour, less men. Inverse proportion. Step 2. Find the relation and solve. So we use the relation y1 by y2 equals x1 by x2 times x2 by x1 times x2 by x1. First time it's with respect to work, second it was for days, third it was for hours per day. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.